When you have a numerical data set, simply listing the numbers is only the first step. To make that data useful, we have to summarize it. Summarizing means giving a description of the data set's most important features using statistical terms, like center and spread, and putting those numbers back into the real-world context they came from. The goal is to paint a clear, concise picture of the information. The most common mistake students make is calculating the numbers without talking about context. For example, if you find the mean is 7, you must say, the mean number of pencils is 7 pencils. You have to mention what you measured and the units you used. Without context, the numbers are meaningless. Context is what transforms a number into a piece of information. One key measure of center is the mean, which is what most people call the average. It's found by adding up every single data value and dividing by the total number of values. Conceptually, the mean is the value each observation would receive if the total amount were perfectly distributed or shared equally among all the items. Let's practice the mean calculation. Suppose 4 students reported spending 10, 15, 20, and 25 minutes on homework. The total is 10 plus 15 plus 20 plus 25, which is 70. We divide 70 by the count 4. 70 divided by 4 is 17 and 1 by 2. We would summarize this by saying the mean time spent on homework is 17 and 1 by 2 minutes. The other key measure of center is the median. The median is simply the value that sits right in the middle of your ordered data set. After arranging your data from smallest to largest, the median is the number where half the data is below it and half is above it. It's often the better summary measure when your data contains a weirdly high or low number called an outlier. Here's why the median is great for outliers. Imagine a data set of ages 10, 12, 13, 14, and 50. If you calculate the mean, it's 19 and 8/10, which is far from the typical age. But if you order the data, the median is 13. In your summary, you would say the typical age is 13 years, which is best represented by the median because the 50-year-old is an outlier. Here's why the median is great for outliers. Imagine a data set of ages 10, 12, 13, 14, and 50. If you calculate the mean, it's 19 and 8/10, which is far from the typical age. But if you order the data, the median is 13. In your summary, you would say the typical age is 13 years, which is best represented by the median because the 50-year-old is an outlier. Let's find the range for some daily high temperatures in degrees Celsius: 18, 20, 25, 29, and 30. The maximum temperature is 30 and the minimum is 18. The range is 30 minus 18, which equals 12 degrees Celsius. You would summarize this as the daily high temperatures varied by 12 degrees Celsius throughout the week. Every summary should also include the count N of observations. The count is simply how many pieces of data you collected. It tells the reader the size of the data set and is necessary for calculating the mean. Always state it clearly. The data set contains n equals 20 scores, so everyone knows how much information was gathered. Remember to explicitly state the context and units you used. Did you measure height in meters or weight in pounds? Was it time in seconds or money in dollars? Your summary should start by framing the data. This dataset summarizes the number of miles run by n equals 10 students, measured in miles. This sets the stage for the rest of your statistics. Knowing the shape of your data is what guides your choice of center. If your data is relatively balanced and symmetric, the mean is the perfect summary. If the data is clumpy on one side or skewed, the outlier on the tail will pull the mean, making the median the more accurate measure of the typical value. The shape is the decision maker. If your data shows a symmetric shape, your summary should rely on the mean. For example, if you see a dot plot that looks like a small hill in the middle, you would state the mean and use the range to describe low variability. The mean is great here because it's not being distorted by any extreme high or low values. Consider this symmetric data. 5, 6, 7, 8, 9. The mean is 7 and the range is 4. Your summary. The distribution of data is symmetric. The mean number of pets is 7 pets, which is the center of the data. The number of pets varied by a low range of 4, indicating the data is very consistent. When the data is skewed or has outliers, you must use the median to describe the center. The summary needs to state the median and briefly explain why you chose it over the mean. You would mention that the outlier makes the mean inaccurate, while the median gives a better, more stable summary of the typical observation. Look at the skewed set. 1, 2, 3, 4, 20. The median is 3. The mean is 6. The range is 19. Your summary. The data is skewed right because of the outlier at 20. The typical number of laps run is best described by the median of 3 laps because the mean is heavily affected by the high score. The laps run showed a high range of 19, meaning there is high variability. The minimum and maximum values are important on their own because they define the boundaries of your data. You can summarize the data span by stating them. For example, the class scores spanned a total of 38 points, starting from a minimum of 60% up to a maximum of 98%. They are the anchor points for your entire distribution. A slightly more advanced way to talk about spread is the interquartile range, or IQR, which is the range of the middle 50% of the data. It's calculated as Q3 less Q1. The IQR is great because it measures the core variability without being influenced by outliers, giving you a more reliable measure of spread. If a set of waiting times has a first quartile, Q1, of 15 minutes, and a third quartile, Q3, of 30 minutes, the IQR is 30 minus 15 equals 15 minutes. You would summarize. The middle 50% of the clinic waiting times varied by only 15 minutes. This is a powerful statement about the core consistency of the data. To create a complete grade 6 statistical summary, use this checklist. State the context and units. State the count, n. Choose and state the best measure of center, mean or median, and explain the choice based on the shape. Finally, state the measure of variability, range. Your summary must connect all these points in simple descriptive language. Here is a final practice scenario. N equals 10 student scores, 70, 75, 78, 80, 82, 85, 90, 95, 98, 100. The data is generally symmetric, with a mean of 85 and 0.3% and a range of 30%. A strong summary. The distribution of the 10 student scores is fairly symmetric. The typical score is the mean of 85 and 0.3%, with a range of 30%. The scores are generally consistent. You've mastered summarizing data in context.